Hello, and welcome to the session FM Area Diversion Project, Dam Operations to Minimize Project-Induced Floodplain Impacts. My name is Joel Paulson, the Executive Director for the Metro Flood Diversion Authority. I also have presenters Greg Thompson and June Young. Today we'll go over a background of flooding within the Red River Valley, as well as a project overview of the Flood Diversion Project. And we'll also talk about project impacts and project operations. So today I'll give you a little background on flooding in the Red River Valley. We're going to take you about 1,500 miles northwest of Raleigh, North Carolina, to the border between North Dakota and Minnesota. The Red River flows north, forming the border between North Dakota and Minnesota before crossing into Canada. Due to the flat geography in the basin left by historic Lake Agassiz, the area has been prone to flooding for many years. The largest population area along the river, which begins at the confluence of the two rivers in southern North Dakota, is at Fargo, North Dakota, and its neighbor, Moorhead, Minnesota. Historically, the North Dakota side of the river has experienced more extreme flooding due to slight geographic differences between Minnesota and North Dakota. I'll talk about the need for flood mitigation. The Red River has reached flood stage about 60 times in the last 122 years. In particular, you can see from the top 10 floods that our 100-year effective base flood elevation is 39.3 feet, and we've exceeded that in 3 particular years, with the most extreme event happening in 2009 at 40.84 feet. Just a few numbers. There's about 260,000 people, along with their homes and businesses, that are currently at risk of catastrophic flooding, and obviously significant economic impacts. In 1997, which was the record at the time, flooding caused $3.5 billion in damages within the Red River Valley, including the almost complete destruction of a sister city to the north, Grand Forks, North Dakota. Millions more have been spent fighting floods since then. However, once the diversion is completed and certified, not only will these costs be prevented, but residents and businesses will be able to drop their mandatory flood insurance requirements. Here's the current period of record for cresting within the Red River Valley. Notice that many of the higher stages are later in the period, and we see a very linear progression of higher intensity and higher increased flood events. Unfortunately, our current floodplain maps are based off of the effective BFE, which takes into account a period of record from about 1903 to 1971. And the current effective floodplain maps do not really encompass the later years in which we've experienced the most intense flooding. After the project is complete, the future BFE will be remapped through a LOMAR process, and we will take into account a period of record from 1903 up until the record flood of 2009, which was at 40.8 feet. Talking about the record flood of 2009, here's a closer look at what it took to fight that flood. We had a crest of about 40.82 feet. That took 69 miles of emergency clay levees, 7.3 million sandbags were used for sandbag levees, 8 miles of HESCO barriers. The effort took approximately 150,000 volunteer hours, and it cost about $8.4 million to implement the temporary flood fighting measures. Next, I'll have Greg Thompson talk a little bit more in depth about the project overview.
Well, thanks, Joel. The primary goal of the project is to provide FEMA-accredited 100-year flood protection for the Fargo-Moorhead metro area. Here you'll see the future 100-year floodplain on the left and the with project floodplain on the right. The project will provide flood protection from 6 rivers. These include the Red River of the North, which flows in a northerly direction, a tributary to the Red River. This is the Wild Rice River that enters from the south. Then the Cheyenne River, which brings a good portion of the eastern third of North Dakota to this location, flows into the project area from the southwest and then along the west side of the metro and discharges into the Red River north of the project area. The Maple River discharges into the Cheyenne River And then two smaller rivers, the Lower Rush and Rush River, also discharge into the Cheyenne River as well. The project will reduce a 100-year flood level from a river stage of 41 feet down to a river stage of 37 feet, which is a 20-year flood event. The second goal of the project is to provide a fighting chance at a 500-year flood protection. This is while implementing additional temporary flood protection measures. On the left would be existing conditions 500-year floodplain, and that flood level would be higher than any of the levees that we currently have through town. And the project is designed to produce a river stage of 40 feet for that 500-year flood event, which would be manageable with the levees. The project has four main components. The stormwater diversion channel was shown in the blue line on the west side of the metro area. The dam and southern embankment, which is shown with the black line on the bottom of the page. And then the in-town levees are shown in purple. And then the fourth component is the mitigation features, which are implemented to offset some of the impacts from the flooding behind the dam. I'll step through each of these in the next few slides. The diversion channel is 30 miles in length, and it begins in the southwest corner of the metro area, connected to the southern embankment and the pool area. It extends around the west side of the metro and discharges back into the Red River north of town. The stormwater diversion channel is being designed, constructed, and operated and maintained for 30 years through what's called a public-private partnership, or a P3. And this entity doing this is the Red River Valley Alliance. Feel free to look them up online for additional information. One thing that's interesting to note is that this is the first public-private partnership for flood protection in all of North America. Now looking into some of the other technical details of the project. So the channel dimensions will vary depending on which rivers are being brought into and where. So at the south end of the project, the channel will be 20 feet deep and approximately 120 feet wide. And then on the north end, it'll be 30 feet deep with the bottom width of approximately 250 feet wide. The channel will have 6-to-1 side slopes based on geotechnical stability requirements. And it'll have spoil banks on either side with a partially embedded levee on the east side there shown in red, which helps with the certification to keep the city protected from that flooding that's in the channel itself. The overall right-of-way corridor of this diversion channel will be 1,500 feet. The diversion channel will intercept 4 rivers from the west. The Rush and Lower Rush will drop directly into the diversion channel. And then the Cheyenne and Maple will have aqueduct structures, which I'll highlight a little bit later. There are 12 additional drainage inlets besides the other rivers. And then from a transportation standpoint, the diversion channel will cross 3 railroads, 2 interstates, and then 12 additional county roads, all of which will pass over the diversion channel using with the bridge structures. Construction began last fall when the contractor purchased over $50 million worth of equipment from local businesses. They have multiple 100-ton excavators as shown here and 40 cubic yard off-road dump trucks to help with the channel excavation and material movement. They've been averaging approximately 35,000 cubic yards per day, and they've typically run 2 11-hour shifts and running nearly every day throughout the year. At the end of the project, they'll have moved 45 million cubic yards of material throughout this 30-mile channel reach. Here you'll see one of the latest pictures from the diversion channel construction from this past winter. This is from the area up in the reaches 1 and 2 area near the outlet as circled on the top part of the page there. So one thing that's interesting about North Dakota and Minnesota is that construction typically shuts down in the winter. However, this contractor is planning to work all year round for the next 3 years. And they've actually found that excavating in near 0 to 10 degree Fahrenheit temperatures seems to work best for moving the clays. There were a few days this past winter when the temperatures got up in the 20s and 30s, and they found that it got to be a little slippery for efficient earthwork. So it'll be interesting to see how things go this summer. As I mentioned, there were 2 aqueduct structures, one on the Maple River and one on the Cheyenne River. These aqueduct structures allow low flows to pass through an aqueduct flume and into the protected area in a controlled manner. And then during times of flooding, additional water will pass over a spillway and into the diversion channel. The second main component is the dam and southern embankment. And this is a 20-mile long dam that stores floodwaters within what we're referring to is an upstream mitigation area. And this is used to offset project impacts, which Jay will talk about here in a few minutes. The average dam height on the north end is 18 feet, and this tapers down to match with existing roadways on both the west side and the east side of the embankment. There are 3 gated structures that will be built into the southern embankment. The diversion inlet structure regulates floodwaters into the diversion channel, and the Wild Rice and Red River structures allow controlled releases into the protected area. I'll touch on these structures with a few more details in the next few slides. The project will store approximately 150,000 acre-feet of water for a 100-year event, with an average maximum depth of approximately 10 feet. There's also an interstate grade raise extending down through the center of the upstream mitigation area, and an additional county and township road raises up and over the embankment. Here's one of the latest pictures of the diversion inlet structure. It has 3 Tanner gates that are each 50 foot wide and 26 feet tall. This structure will be completed this summer with a cost of approximately $46 million. The Wild Rice structure has 2 40-foot by 40-foot Tanner gates, and this structure will be completed next year with a cost of just under $60 million. The third structure, the largest of the 3, will have 3 50-foot wide by 50-foot tall Tanner gates on the Red River. Construction for this structure began this past fall, and it will be completed in 2026 with the rest of the overall project. This is the largest and has the highest cost at $115 million. The third main project component is the in-town levees. They're also referred to as the local entity flood protection. These are shown basically levees and flood walls shown in the top right in the map there throughout the Fargo and Moorhead metro area. Levees and flood walls, as well as stormwater pump stations and other infrastructure that's necessary to handle the flows that are going to be passed through the main rivers. This picture shows a flood wall and stormwater pump station in downtown Fargo. The fourth major component is mitigation features. This includes rural residential as well as commercial structure removal from that upstream mitigation area behind the dam, and then relocation of these structures, a lot of times along the fringes of the floodplain in higher ground. The project will also include flowage easements. Here in the kind of the blow-up picture there, it shows a zone 1 and zone 2 in the orange and the purple, and that's a federal mitigation zone where impacts are greater than 1 foot. And then a very small piece of green is a North Dakota mitigation zone where the impacts are between a 1/2 foot and 1 foot. And then the pink in Minnesota is where impacts are greater than a 1/10 of a foot. The mitigation features also include several community levees. Right in the center of that orange there is a ring levee around the city of Oxbow, the community of Hickson, and then the rural subdivision Baki. Off the map to the south, approximately 4 miles, is another levee for the city of Christine, where the impacts are just over a foot with the project. And then the city of Wolverton is about 7 miles off the page to the south and upstream, where the impacts from the project are approximately a 1/2 foot. The city of Georgetown is at the downstream end of the project that will receive additional flood mitigation measures. Then there's a number of environmental mitigation features as well. Drain 27 is a legal drain that is cut off by the southern embankment, and this has been converted into a wetland mitigation site. And then Drayton Dam is a dam downstream of the Fargo-Moorhead area that will be implemented with some fish passage mitigation measures. A couple other rivers, Lower Otter Tail River in Minnesota and the Cheyenne River in North Dakota, will be restored through this mitigation effort as well. With that, I'll turn it over to Jay to speak on some of the project operations.
Thank you, Greg. As Joe and Greg introduced, the overall goal of the project is to provide permanent flood protection for the Fargo-Moorhead area. The operation is to reduce flooding through metro area, and another very important piece is to minimize Red River downstream and upstream mitigation area impacts. In the next few slides, I will show you how does the operation generate impacts without operation rules, and how do operation rules mitigate those impacts. The project provides flood protection to the metro area, and by doing that, it reduces a large portion of existing floodplain storage. In addition, the diversion channel is more efficient than the natural river, so water flows around the town faster than it does through town today. Red River is roughly 60 miles, and then the diversion channel is roughly 30 miles. Under existing conditions, there are 7 rivers drain to the downstream end of the metro area, downstream of the future project, to generate this green hydrograph. What would happen with the diversion channel but without storage? The flow through town is restricted, and additional flood water would flow through the diversion channel, which generates this purple hydrograph. The flow arrives downstream much earlier and produces a higher peak, which generates downstream impacts. And next question is, how to mitigate these impacts? The solution is to store this flood water in upstream mitigation area, and then release it later when flood peaks pass through and produce similar flood peak at downstream similar to the existing conditions. The only operational component of the project are tender gates within a southern embankment. As Greg mentioned, there are 3 sets of gated structures: at inlet of diversion channel, on the Walrus River, and on the Red River, work from left to the right. By operating these gates, flow through metro area will be reduced, flow through diversion channel will be regulated, and flood water will be stored in upstream mitigation area. In the next few slides, I will give you a tour of flood operation through the progression of flood hydrograph. The example hydrographs and flooding here are from a 100-year event. During non-flood times, Red River structure and Walrus River structure will be open. Diversion inlet structure will remain closed. As snowmelt runs off, stream gauges will be monitored, and flows will be recorded at 2 upstream gauges. Here you will see the blue hydrograph is combined Abercrombie and Inlow, the 2 upstream inflows to the project from Walrus River and from Red River. The red hydrograph is going through southern embankment and then drain water through the town. The yellow hydrograph you will see in the next few slides, its flow going through the diversion channel, and then green dashed hydrograph shows the stage hydrograph of upstream mitigation area. The project only operates when the flow come in the project exceeds 21,000 cubic feet per second, which is equivalent to a 20-year event. So there's 5% chance of project operation in any given year. If the flow is less than 21,000 cubic feet per second, the project will not operate. When the flow exceeds 21,000, project will begin operation. At this time, flows will be recorded at the Red River structure and Walrus River structure. Flow will remain constant through the town. So you will see this red line extends horizontally. At this time, the upstream mitigation area will start store water and diversion inlet structure gates will remain closed. Stream gauges will continue to be recorded and flow through the town will be increased to that design threshold. This design discharge through Walrus River structure and Red River structure is calculated using a discharge volume relationship, which is a function of flood volume within the upstream mitigation area, as well as real-time upstream inflows. This is a nonlinear exponential relationship that is well calibrated using many synthetic and historic events to calculate the optimal discharge releases from the pool area to minimize the downstream impacts. You will see this red line will increase based on the designed calculated discharge, then it will level off to produce a 37 feet stage through the town for the 100-year event. Any excess flow will be passed to the diversion channel through the diversion inlet structure. Following the flood crest in upstream mitigation area, the dam will continue to release flows through the diversion channel and through town as the flood recedes. And you will see this yellow line, diversion flow starts to extend up. The maximum flow for the diversion inlet structure will be 20,000 cubic feet per second for the 100-year event. Water level in upstream mitigation area drops down, the gates will return to their original positions and prepare for next flood. The operation interval varies from 1 hour to 6 hours depending on different stage of the operation, and then also depends on the magnitude of the flooding events. Operation rule is robust to handle flood events larger than a 100-year event. For the 500-year event, flows through town will be increased to 40 feet. And then flow through diversion channel will be increased to 25,000 cubic feet per second. If the flood event approaches to IDF, inflow design flood, roughly 80,000 cubic feet per second inflow. The diversion gates will be wide open, flow through town will be held at 40 feet. Project will also accommodate flood operation up through PMF event, proper maximum flood, which is roughly 6 times larger than a 100-year event. Evacuation order will be sent out, and all 3 saddle gate structure will be open to send additional flood water through the town and diversion channel, while maintaining a maximum pool elevation of 23.5 feet to protect 1,000 embankments. Here's a flow chart we put together to provide operators with a step-by-step instruction on how to operate gates real time. Now I will turn it back to Joy for final closing thoughts.
You can follow along on the progress through our website, newsletter, and social media channels. And if you're ever in the area, we certainly would be happy to give you a tour as well. Thank you.